Hi, my name is Sanas Manahi, and along with my team, we'll be presenting our graduation project proposal presentation. These are our contents which we'll be presenting today. Our project definition is the robot will start traveling after the passenger uses user interface to connect with it. Robot will move autonomously to the location, and using image phrases, the robot will stop or continue if there's an obstacle on its way. In this definition, we use mobile application and over the Wi-Fi network, it will connect to the autonomous vehicle. And autonomous vehicle will use localization and mapping and path planning and precision systems to ride to the desired location of the passenger. Our motivations are bring solution to the traffic, minimizing carbon emissions by reducing the number of vehicles, preventing human-related accidents by using autonomous vehicle concept. Our goals are lane tracking with perception system, SLAM, and path planning, requesting the vehicle with a mobile application, and instant location tracking. Our stakeholders, for example, you could see that the majority of them are passengers, or for example, the rental companies, and etc. Our technical requirements, for example, the vehicle must detect an obstacle from 10 meters away, so there won't be any accident. In our literature review, we used many similar autonomous vehicles, such as Google Waymo, which is currently in use in USA. For example, the passenger can request over the user interface, and it will autonomously drive to the passenger. In our system architect, we have the user and the mobile application, which will connect to the autonomous vehicle using server. And this autonomous vehicle will use sensors and the data from the sensors, along with localization and mapping and path planning to autonomously drive to the location of the passenger. In user interface, both Kiwi and Kiwi MD libraries are used. Kiwi MD library is mostly for design to make it look more professional, and Kiwi is used for example, login page or password page, or for example, mapping. For the communication user interface and the vehicle, MQTT protocol communication protocol is used. MQTT can transmit location information from smartphone to the application server or from the application server to the autonomous vehicle. In this communication, we use a Pahoe MQTT library of Python to communicate the application and the vehicle. For example, when a user requests a ride using the application, the smartphone can publish a message containing the user location to the MQTT topic on the application server. The server can then subscribe to the topic and receive the message which contains the location information. The server can then use the information to dispatch an autonomous vehicle to the user's desired location. In this situation, application acts as the MQTT publisher and the vehicle acts as the MQTT subscriber. MQTT broker, for example, which are the servers, for example, Hive and Mosquito, they are both free servers which could be used for MQTT as a server.
The applications to be realized for the shared autonomous vehicle are analyzed in 3D environments such as Gazebo and Arvis. Within the scope of this project, Jackal was preferred among the mobile devices mentioned above. Physical similarity to the vehicle to be used in the implementation of the shared autonomous vehicle having features. In this project, Jackal's algorithms were arranged, developed, and used for the simulation of the autonomous vehicle. A cost map consisting of several layers was created for SLAM. The first layer is an empty grid map. The second layer contains obstacles according to the data from the leader. The third layer contains virtual obstacles created according to the lane lines on the road. In the fourth layer, there are virtual barriers created according to the traffic lights and traffic signs. Uh, this is the navigation stack, the ROS navigation stack that we used in this project for navigation. We wrote some codes for lane tracking, and we used this data in SLAM. We used YOLO v7 for object detection, and we connected YOLO v7 with ROS. In the implementation, we installed Ubuntu 20.04 on JSON Nano. After that, we connected camera to JSON Nano, and we made the connection between camera and ROS. There is the image view of this camera, and we connected the LiDAR to JSON Nano, and we made the connections LiDAR with ROS. In these pictures, in these photos, there is laser scan the data of LiDAR in Arvis. You can see in Arvis. These are softwares we used in this project.
Hi, I'm Berkay Gazneli. This mobile robot's graphic processor is Jetson Nano. Main controller is Raspberry Pi. Jetson processes the raw data from the camera into meaningful outputs. Jetson then communicates with SPI communication and sends the outputs to Raspberry Pi. The Raspberry Pi sends a signal to electronic speed controller and the electric motor starts up. Jetson also processes slider data. IMU and GPS sends their data to Raspberry. Jetson Nano communicates with the mobile application through the Wi-Fi module. The system is powered by a battery with capacity of 5200 mAh. A DC-DC converter reduces the voltage to a suitable value, allowing the components to be used. The electronic speed controller to be used in this project is an open source project called Weather Electronic Speed Controller. Within the scope of the project, some minor changes have been made in the circuit and do not affect the main system. This electronic speed controller enables the brushless DC motor to drive. The mechanical design of the project is as in the image. The front axle will be controlled with a help of a servo motor. The brushless DC motor will transfer its power to the rear axle with the help of a differential. The main structure of the chassis will consist of aluminum hollow bars. The rods will be connected with the necessary fasteners. A controller mechanism is needed in order for our robot to proceed smoothly and to improve its movements. There are various methods for this. There are methods such as PID, pure pursuit. Tracking will be done using pure pursuit control on our robot. Here you can see our work schedule. We are now at the end of the 5th week and we are planning to start work of week 6. Here you can see our task distribution table. During the project process, we have the following parts: Jetson Nano, Raspberry Pi, RP LiDAR, LiPo battery, and PixieCam. The following products are in the procurement process: IMU, GPS module, servo motor, DC brushless motor, and DC-DC converter. Leo Drive is our sponsor of the project. On the other hand, our project was entitled to receive support from TÜBİTAK program. We will use part of the project budget from the money that will come from here. Thanks for listening.